Hello again, here we are on page 191 and we're just doing some Pythagoras. So the angle is not referenced, so it doesn't matter which label we put opposite or adjacent. So the longest side is 10, so 10 squared is the hypotenuse, is equal to 6 squared plus 8 squared. Multiply them all out and we see that 100 is equal to 100, so it is a right angle triangle. There's just a recap on the hypotenuse squared equals the adjacent squared plus the opposite squared. Okay, that's Pythagoras. Substitute in for C, 10 squared is equal to 9 squared plus the square root of 19 multiplied by itself will simply give you 19. So 100 is equal to 81 plus 19, and that is indeed correct. Okay, for D. Okay, so we set up the equation according to Pythagoras. 15 squared is equal to 10 squared plus 12 squared. Let's see if it is indeed equal. 225 is equal to 100 plus 144. It's quite clear that 244 is not equal to 225. So 225 and equals with a line through it is basically saying not equal. So 225 is not equal to 244. So it is not a right angle triangle. And on page 192, let's have a look at question 6, x squared. So we're not given the hypotenuse this time. So x squared is going to be equal to 20 by 20 plus 21 by 21, which gives you 841. Find the square root of both sides. So x squared equals 841. Square root of x squared is x. Square root of 841 is 29. Question 9. Pythagoras states the hypotenuse squared is equal to the opposite squared plus the adjacent squared. 10 squared equals 8 squared plus the adjacent squared, because we don't know what it is in this question. 100 is equal to 64 plus the adjacent squared again, which we still don't know. Okay, at this stage we need to isolate the adjacent squared, which means we need to get it on its own. So in order to do that, we need to subtract minus 64 from both sides. And we end up with 36 is equal to the adjacent squared. Find the square root of both sides. And 6 is equal to our adjacent. Okay. Question 17, part 3. We're given three numbers, 13, 12 and 5. 13 is obviously the hypotenuse. So 13 squared is equal to 12 squared plus 5 squared. Okay, so let's see, does that actually work out to be equal? So 169 is equal to 144 plus 25. And that is indeed correct. 144 plus 25 gives you 169 on the right hand side. And on the left hand side we already have 169. And therefore they are a Pythagorean triad of those three numbers. So those three numbers can be substituted into Pythagoras and prove Pythagoras to be correct. They are known as a Pythagorean triad. Okay, let's have a look at question 17, part 2. So here I have page 192, question 17. And I'll call it part 2 for purpose of the video. So it's part A, VII. We're given three numbers, 34, 14 and 7. 34 is obviously the hypotenuse. 24 squared equals 14 squared plus 7 squared. 1156 is equal to 196 plus 49. But when we add them up, we see that it just gives a value of 245, and that is clearly not equal to 1156. So in this case, therefore, it is not a Pythagorean triad of numbers. And we're done.